we'll give it a few seconds here, but we'll get started soon. Be starting here soon. Yeah, I don't think we should.
That's pretty good. The buzzing is almost non-existent compared to what it was.
Yeah.
I think it's just because that mic's probably on.
Okay. Welcome everybody, Stokes, thank you for coming to the Spokane .NET User Group. Today is a kind of different style event. Microsoft has a season of AI, so they have some content that's curated. Casey's kind of used that as well as his own content to create a AI-focused talk for us today called Generative AI for .NET. This is the June edition of the Spokane .NET User Group, and I'm going to turn it over to Casey. He was very happy and very excited to do the announcements for me, so I'll let him go away with it.
All right, let me make sure I'm on here. Perfect. All right, so again, thank you and welcome to the Spokane .NET User Group, Generative AI for .NET. As Dan mentioned, this is a part of the Season of AI, a Microsoft community pilot. Just some quick items here to go through. Today's meetup is sponsored by Intellitect. Thank you, Intellitect. Leaders in software architecture and software design, passionate about learning, and highly active in the community and actively hiring senior devs. If you want to find out more about them or give us a holler, you can find us on Facebook, Twitter, or on YouTube. And finally, the Spokane .NET user groups that are sponsored by Intellitect. We have the Spokane .NET user group. We're here today. The DevOps user group, the Python user group, and the Rust user group. So if you're interested in any of those topics or any of those user groups, go on meetup.com and you can find out more. So, getting started, as Dan mentioned, my name is Casey Schadewitz. I am a software engineer here at Intellitect. I'm a certified Azure AI engineer and data scientist, co-leader of Intellitect's first Azure AI engineering cert cohort, a longtime AI enthusiast, a late adopter of LLMs, funny enough, but an early adopter of RAG, which is going to be a key piece of our topic today. Really quickly, I would like to ask you if you could go to this QR code and give us a response on how we do today. Would be greatly appreciated. This will also be available at the end. So, can AI write the talk for you? Pretty standard joke. I think we all kind of feel this way or think this way now with everything so powerful and all the cool, interesting abilities that people are enabling through generative AI. So I'll pose the question to you. How much of this was written for me? Did I write any of this? It's for you to find out. And we'll jump really quickly into a demo. I do want to apologize really quick. I'm not a front-end web dev. You will not have a pretty website to look at. You are going to get console, because this is where I live. So not a whole lot to see here. We've got a little chat going on. Hello, I'm your Essential C# Copilot, using the information from the web sit. Wow, can't spell either. I will do my best to answer C# related questions. How can I help? So a little bit of context. Intellitect's founder, Mark Michaelis, was actually the author, and still is, of the Essential C# book. I can give you guys a quick view of that. So there's now a digital copy of this book. You can find it at essentialcsharp.com. All of the wonderful information that you'd find in the book, except for kept up to date, fairly real time, as opposed to getting a new one every year. And this is the source of the information that we will be getting responses for. So let's ask a question. There we go. What is a method? Pretty easy question. Let's see if our AI knows. Yeah, we do have a train going by. That's not the issue, though. Funny enough. Let me see here. Looks like my service is dead. Sorry about that. Let me start that back up real quick. All right. Let's try this one time. What is a method? Wow. You know, when it works once and then it stops working as well. I will try to resolve that here, but not now. We'll move on, and I promise that we will get some wonderful AI hit content here at the end. So, moving on past the wonderful demo, pretty poor at best. Let's take a look at some of the stuff that went into this. Generative AI. I'm supposed to say that that demo had a lot going on. You didn't see the demo, so sorry about that. But let's talk about some of the things that go into building that system that I'll show you later, I promise. So LLMs. We'll first start by defining them. Large language models, commonly referred to as, or abbreviated as, LLMs, are a type of generative AI that is trained on natural language and uses statistical patterns to understand natural language from a huge volume of text, pretty much the entire internet, books, articles, websites, social media, pretty much anything that's text has been used to train these generative AI models. An LLM works by estimating the probability of the next word or token. We'll get into what tokens are a little bit later. Or the next sequence of words or tokens given some previous tokens as part of a prompt. So you can see here we've got a small prompt, once upon a time. We shoot that over to one of the GPT models or one of the numerous other generative AI models, and we get a response called a completion. The LLMs repeatedly predict the next token using the context of the prompt along with the other tokens that it is guessed prior, predicted prior to that token that it's next trying to predict. Phrased another way, you can think of these models as being trained on the entire internet, and so they represent something like 100x compression of most of human knowledge. They fit into a size of about 140 gigs. So fairly large, but in the context of all of the internet, pretty small. The models are optimized by next word prediction using self-supervised training loops, meaning hiding part of the input text and seeing if it is able to guess the next token, and then using backpropagation to learn from that. So, LLMs, that's pretty much it. I mean, really you have to ask, you have to have the entire internet to predict next word? Pretty pathetic. But really, you interact with these models by inputting a prompt, getting a series of tokens back, and that's pretty much like the basics of LLMs.
So does GPT only interact with LLMs, or does it interact with other things? Because like I've heard of is GPT part of a LLM only, or is it part of a broader thing?
So GPT can probably best be described as a family of LLMs. GPT 3.5, 4, 2, I mean, OpenAI has been producing GPT models for quite a while. I mean, obviously it gained the most notoriety on ChatGPT, which is based on GPT 3.5. However, it is a subset of LLMs. Now that's not to say that LLMs are the only language models. The Phi 3 models that Microsoft has been producing or has recently released, called or referred to as SLMs, small language models, are also a language model. So, did I answer your question? Great. Okay, so the language model receives raw text. Tokens are chunks of text depicted by the colored boxes on the screen. These tokens are then transformed into integers and fed into the model. The model is a transformer-based architecture. It is also a neural network, which we don't have time to dig into, obviously. That topic is got hundreds of people PhDs. We don't have time for that right now, but maybe someday. And honestly, I probably am not the best to answer it anyways. But essentially, the goal of the models is to predict the next word in a sequence, which leads to the model sampling a probability distribution that results in the final text or output tokens. General idea, you get text, turns into tokens, it goes to the model, and then it gives you back text. So, how do they work? As I said, you get n tokens in, you get sequentially one token out at a time. Now, when you get a response from something like ChatGPT, it's obviously aggregated all of those into one response that it then serves to you. But what's a token? So, a token is not a word, or not a letter, and a token is not a word. Rather, a token is a set of one or many characters from a piece of text that ends up representing what is the vocabulary of the LLM. Now, it turns out that in English, most tokens are between one character and one word, but it doesn't always have to be that way. Most LLMs use a variation of what's called byte pair encoding to do its tokenization, and it's probably most succinctly an article, or in an article called Comparing GPT Tokenizers, a Sweetie Tripathi. Byte pair encoding was introduced in the paper Neural Machine Translation of Rare Words with Subword Units. BPE, byte pair encoding, works by merging the most frequent pair of characters in a corpus, single token, until a desired vocabulary. This approach has shown to be effective in capturing both morphology and semantic information of the text. In the case of OpenAI, a token is a short sequence of letters. For example, we can see here, we is a token, of is a token, or need is a token, to is a token. And because they are short and commonly used, they represent their own individual token. Rarer words like anthropomorphizing obviously is not a very common word, and so it ends up getting broken down into several smaller pieces that actually represent a more commonly found set of characters. This is a representation of, I believe, the GPT-3 tokenizer, but as I said, not all tokenizers work the same. And even between GPT models, they are different. So let's take a quick look at a tool provided by OpenAI to review these tokenizers, or to understand these tokenizers a little bit better. All right, so we've got here GPT-3 tokenizer, GPT 3.5, and 4 tokenizers. They share a tokenizer. And same piece of text. We get our 11 tokens, our 4 to 3 characters, split up in the same way as in the image. However, if we switch to the 3.5 or 4 tokenizer, you can see it's actually more tokens, same number of characters, and split in a different way. So we've got these same we, need, to are all the same tokens as they were with GPT-3, but anthropomorphizing has actually been split differently. So this is kind of just a quick view of tokenizers, about them. Take it just a tiny bit deeper too. So let's see here. As we saw, tokenizers for 3, 3.5, and 4 are different. They produce different results, meaning they have different vocabularies, actually, that they use to consume and produce language. Now, before we move on, I'm going to mention another language or technology. Please forgive me. Python. I said it. Don't hurt me. So what you're seeing here is actually a piece of documentation from the tick token library, or from their repository. Tick token is a Python library that is supported by OpenAI and provides you an API or a programmatic way to get tokens the same way that it would inside of the LLM. So this is great if you want to make sure you're minimizing the number of tokens you're sending into a model. I mean, it does cost money. It's relatively cheap in the grand scheme of things, but if you want to check your the size of your prompts prior to doing so, you can use tools like tick token to do that. Now, .NET shouldn't feel left out. There are third-party ports of tick token, specifically Token Sharp, I believe, and tick token Sharp. Sharp token and tick token Sharp. Everything has to have a Sharp. What can I say? And they also support both the CLK 100 or CL100K base, K base that are used by 3.5 and 4, I believe. So, why is this important? As we were talking about before, it takes in tokens, iteratively moves through those tokens, and expands the window to garner understanding from the input text or the prompt. You give it tokens, it produces out 1 token at a time, like we see here. It incorporates the output as part of that input as it produces it, so that each successive iteration uses the understanding that it's already gotten or that it's already produced as it's continuing to predict what the next best token is to produce. So, question obviously is it deterministic? The answer, no, it is definitely not deterministic. What it really does is it doesn't just get a token, it actually produces a probability distribution, as was mentioned earlier. And then it uses this probability distribution to determine what token it's going to predict next. There are some ways to affect what tokens it chooses. Not directly, although, actually, no, there is ways to directly do it. There's current research that's going on into exploring the probability, or the embedding space of these large language models. But again, we don't have time to get into that either. The two things that we can use that are simple are temperature, which is often done as a 0 to 1, and controls the creativity or the randomness. So if you have multiple tokens that have close to the same probability, it'll take that group and then randomly choose one, as opposed to just strictly taking the highest probability token. The other thing is that you can actually, if you run these iteratively, you can actually get more than one token out. Not to say sequential token, but you could get the top 5 of these tokens so that you can see what it's going to predict or what the options are. And that's using the p-top value in the input to these models. So if you go with a low number on temperature, you get very focused, very deterministic output. If you go higher, you start getting more creative. And this is really important for just kind of your use case.
So, sorry, quick question. When
Yeah.
you're talking about, okay, so it's not deterministic, does that mean like in the demo that you did, when you asked what is a method against that same kind of model, I'm assuming, which was the essential C# book, would you potentially have gotten a different answer the second time you asked it?
So
Or would you always get the same answer with that same set of...
there's a couple different pieces that really go into that. What?
Repeat the question.
Oh, yeah. Okay, yeah, sorry. So the question was, in the demo that I didn't get to do because it broke, but the question really is, given a prompt, since these are non-deterministic, are you guaranteed to get the same, or are you not guaranteed to get the same response, or are you going to get a different response every time you ask? It depends. So if you're looking at like a base LLM, like talking to ChatGPT, and you ask it the same question, I don't know what they set their temperature on behind the scenes, but if the temperature is pretty close to 0 or set to 0, you should get approximately the same answer every time. That, like I said, does change at temperature. Now, with REG, which is what this demo ultimately will hopefully be here momentarily, if I can fix it. It depends, because as we'll get into a little bit later, you may have different information to base the answer off of, or the LLM may have different information to base the answer off of. So let's talk about something that everybody knows about, or at least everybody's heard of, prompt engineering and why it's important. So prompt engineering. We've talked about prompts, natural language. Prompts are the instructions to these models. So they're how we communicate with them and get them to produce responses. Prompt engineering is almost like configuring your model. So if you ask a model to please give you an answer, it's actually more likely to give you a good answer than if you curse at it or talk to it disdainfully. Why? I think the answer can probably be best found if you look at the majority of text that it's produced on. So, like humans, in our writing, we get the best responses when we ask nicely. And because the models are trained on this information, they seem to be like exhibit this same behavior. Kind of an oddity thing, or an odd thing, because they're not alive. But they seem to like people being polite, I guess. I don't know. It's kind of interesting. But there's two kind of ways to prompt a model or to draft your prompt. You can provide it with an instruction and your primary content. So you could say something like, please translate X to Spanish, or some sentence to Spanish. And so you've given it an instruction, please translate, and then you've given it kind of like the content of what it should do. Same thing with like, please summarize this, and you give it information to summarize. Another way you can actually use LLMs is to do completions. So you give it a piece of text and have it complete the sentence, similar to the one we showed earlier, once upon a time, in a quaint village, yada, yada, yada. That would be called a completion. And you can also ask it direct questions. So you can ask it, what's the capital of Wyoming? I don't know, but I'm sure the LLM does. But one thing to keep in mind there is that it is only able to answer, at least accurately, with knowledge that's inside of its training base. So one of the things that any of the earlier users or users of ChatGPT from when it first came out would know is that if you asked it a question that was not answered prior to 2021, you were not going to get an accurate response, or you were going to get no response, as in it would tell you that it didn't know. However, there are ways around that, and that's really a big piece of what we're going to be talking about here. And of course, I forgot to press the button, so sorry about that, guys. But moving on, another thing to use, or that you can use as a developer, is what's called a system prompt. This is outside of the user prompt, which is kind of what we talked about earlier. But the system prompt allows a way, or gives you a way to, without providing visibility into it to the end user, give the LLM some additional instructions. Often this is used for kind of like fine-tuning how you want responses to be produced. You'll often see things like, please answer in a concise and accurate manner while getting to the point immediately, so you don't have an LLM that's kind of just rambling. Or you'll say, you are a friendly assistant that is here to answer questions about X and Y. And using this, you can kind of steer the way the LLM will answer questions. Its tone, its kind of writing style, and its kind of focus area. Go ahead.
Is that how they do like the security aspects? I know Microsoft keeps saying, that it's, make sure that it doesn't give data to someone who doesn't have permission to see it.
So that is actually, well, that's handled on a couple different levels. And I'll have to find it at the end and I'll share it, but I want to say it's called Lakera or Lakra.ai. There's a firm that's put together like these little games. I don't know if you've seen the Merlin games, where you try to get Merlin to answer your question, and it's always about trying to get it to share a password with you. And it successively gets harder to get it to give you the response. And the way that they actually handle that is a couple-fold, or a many-fold. So you can do an adversarial model, or like a guardian model. So a model that sits in front of the model that's actually going to be answering the question, and have that model tell or predict whether the prompt that's being input by the user is contains stuff that would what they call jailbreak the end model. You can also do things like putting another model at the end. So you take your output from your first model, and you actually feed it into another model and ask it things like, is there a password, or is there sensitive data in this model? So those, and there's really a bunch of other ways to do that, are some of the ways that it's handled from a kind of an LLM perspective. Beyond that, though, you also have integrations with RBAC or ACLS systems, where with Copilot for Microsoft 360, it'll actually use the rights that you have in your AAD or your Entra to determine whether or not that file is available to you. So it will go and find files that have your permissions or that you have permissions to, and then use those files to answer the questions. So there's a couple different ways to handle it, but there's still a ton of research going on into it. And it's, in my opinion, not a 100% solved problem, but there are a lot of safeguards that are out there that you can put in place. All right, moving on. Talking in text. So, this list is by no means exhaustive, but here are some of the most common use cases for text generation that we can encounter in startups or in businesses. We've seen ChatGPT-4 Turbo being used for creating diverse texts for websites, social media, marketing, product descriptions. So replacing kind of that copy creator, creating copy. Summarization, so summarizing complex documents or generating like product manuals, legal briefs, regulatory filings. Assisting engineers in writing code. Anybody that codes should probably have seen Copilot, GitHub Copilot at this point. Semantic search, which we'll be digging into a little bit later. And then developing chatbots, which is kind of all of this, or the capabilities above kind of put together. Three key approaches to prompt engineering for text generation that you will see in our upcoming demos. We'll see. Defining a assistant persona, so the tone, style, chat history. Talked about that a little bit earlier before. Providing examples or context data called meta grounding. And then providing guardrails or mitigating fabrications. So make sure you only use data that is in your relevant information section. Again, we'll dig a little bit deeper into that here in just a moment. But first, let's talk about talking in numbers. So embeddings and semantic search. So computers ultimately talk in numbers. They don't actually speak English. They don't actually understand words. So when we send text into a model, we actually need to do an embedding. So an embedding is a way to take text and turn it into a numerical form that represents the relationship between the words and the concepts. This is a step beyond tokens and actually captures semantic meaning. So embedding models, as I said, take text, transform it into an array of numbers or a vector, which represents that original semantic meaning. The OpenAI Ada model is a large language model or a large multimodal model that can take both text and images and turn them into an embedding or a vector. It generates these to encode meaning of your context or your prompt. And for example, here we've got today we're going to learn about Azure AI Studio. And we send that into Ada, and it produces this wonderful vector on the far right. Now, this is obviously a subset of the actual numbers that are here, but Ada will produce a 1536 dimensional vector or embedding that represents that text. Those 1536 dimensions are referred to as the embedding space. What is that great for? Semantic searching is what it's really great for. So let's imagine, since I can't think in 1536 dimensions, a two-dimensional embedding space. Nice and simple. We've got royal to not royal, female to male, male to female, kind of left to right. So let's start embedding some words into this embedding space. We'll start with king, fairly royal, fairly male. Princess, female, fairly royal. Let's add peasant, definitely not royal, but not really gendered. Then let's add a bunch more. So we've got queen, ruler, duke, butler, maid, all kind of in their space or their, their area of this embedding space. So now let's say that we're looking for things that relate to emperor. And we want to find two things that relate to emperor. What do we think is going to be returned if we look for emperor? King and duke. They're both very male, both very royal, as is emperor. But how do we do this technically? Well, we embed the knowledge base. That would represent the king, the duke, the ruler, the stuff that we put in there first. And we put that into a vector database. This is what we use to store these, what are called semantic memories. Then we take our prompt or our question, what we're looking for, our query, that's a better word for it, emperor. And then we use the embedding model to embed that as well. And we use, if you remember linear algebra, any of you that remember linear algebra, it was a lot for me, but we use what's called cosine similarity or things like k nearest neighbors, different algorithms from linear algebra or that represent linear algebra operations to find the nearest neighbors or a cluster of things that all go together, like you'd see here. Now, this, thankfully, doesn't require me to have a working system. So let's take a quick look at some of the embeddings. This is my vector database that represents all of the knowledge that my LLM, or rather my copilot, would use to answer those questions. If I can grab, we really need to get a presenter screen. So in here you've got your ID, some information that represents, what this is actually the embedding for. The embedding itself, the vector, which is very long, as you saw when I was scrolling, 1,536 dimensions, because I do use the ADA model. Some additional metadata referred to as tags in this instance, and the actual original content represented by that embedding. Seen there. Any questions about embeddings, embedding spaces, vectors, vector databases?
Sounds like it's similar like the SQL SoundX as far as finding the thing closest.
Yes, yeah. So, yeah, exactly. It's finding the thing that is most similar to the query. I'm not super familiar with SoundX, but I don't think it's semantic.
Yeah, I don't think it's like the concept of it.
Yeah, no, exactly.
Search for something, but it's like, I'll give you something that sounds the closest to this.
Yeah, no, it is exactly like that, just for semantics or for meaning of the context. So moving on from there. Oh yeah, I gotta switch back to my slides. My bad. There we go. All right. So, executing custom logic. Now, I don't have this great thing that I can tell you about it other than LLMs are just not good at some things. If you've ever tried to take a complex math equation, or even really a basic math equation that includes, let's say, like a 10-digit number added to another 10-digit number. It is atrocious at answering these. And it relates to the way that the LLM tracks the importance of things as it's going through its tokens. Honestly, it's over my head. I just lightly read somebody's PhD paper about it, but they're very bad at it. So what we can do is we can actually give LLMs that ability by allowing them to execute or have code to execute outside of the model itself. One example of this is function calling that's supported by Azure OpenAI, other AI systems. But really, what it's doing is it's taking a query or a question, and then it's taking that in a meta prompt and producing a JSON or really any kind of structured data format, which can then be passed into like an API. So here you'll see that you're an AI assistant designed to help users search for hotels. When a user asks for finding a hotel, you should call the search hotels function. So below is kind of a description or a schema for that. And what it would do is it would take the, I want a hotel with a private beach, cost 300 euro max, and in Damaris. And it would produce location Damaris, max price 300, and you could imagine that there's an API on the other side that then consumes that request and provides a response, which can then further be fed back into the LLM to then produce a nice natural language answer to that.
So does it do that by, basically it knows it needs location and max price, so it's looking at that and saying, which of these is most likely to be location, which
Yeah.
one of these is most likely to be price?
Yeah, that's exactly it. So what's actually happening is you have, let's say your user, they put in that prompt piece, and through what's called or referred to as orchestration, you would actually take that original prompt, you would run that through a model, and it would do something or have another like system prompt that's saying like, from this query, tell me out of this list of things, capabilities, functions, plugins, what do you think is going to best answer this prompt, or what will be useful in answering this prompt? And then you'd get that answer back. You'd then grab the function or the schema for that, pass the schema and the prompt back in with a system prompt similar to the one above. Your AI assistant designed to search for hotels using this function. It would then produce a response that would then fit that format. So really that capability is not built into models. It's something that we would build as developers using some kind of orchestration framework or even custom orchestration if you really wanted to get crazy. But there's people have already done the work for you, so don't rewrite or don't reinvent the wheel. But it's really cool. And one thing to keep in mind for those of you that are interested in this, producing structured text out of an LLM, there are some LLMs that are good at some structured text formats and others that are good at other ones. So an example of this is the GPT family of models are really good at JSON, and they're also really good at Markdown. But and I want to say it's not Claude, BERT, the Google family of ones, and I believe Gemini ends up with the same kind of issue or quirk to it. They're better at producing XML. Why? I don't know. Probably has something to do with training data, with the fine-tuning, the expert fine-tuning that's done to it, but they just are. And it's some of the intricacies that as you work with different models, you can find, and just know that there are quirks like that. So demoing functions. This is the part where I would run a demo, and I'd show you that without a plugin or without the function available to the model, it's really bad at doing a 10-digit addition. And then I'd use the plugin, and it would do 10-digit addition. It would be great. And again, it's really because it first looks at the prompt, determines what it's able to do to outside of the LLM to kind of help us in assisting answering that question or that prompt. And then it does that, feeds that back into the LLM, and you get an answer. All right, model knowledge. So we touched on this a little bit before, but models have a training date. They have a set of, they have a cutoff in their knowledge going to a certain time. You can see here GPT-4 32K. Its training date or the cutoff date is September 2021. Same with 3.5 ChatGPT, the one we all first played with. But the more recent models of GPT-4 have a cutoff date of April 2023. So this is great, but you still end up with problems with recent questions. So asking things that happened after its training date. And so what you'll see here is Queen Elizabeth II still alive? As of my last update, Queen Elizabeth is still alive. However, please note this information may not be up to date, so I recommend verifying with a reliable source. So it's not sure because it knows that it doesn't know all the way up to the current time, which that's kind of an oddity too. I'd be willing to bet that this is actually produced using a meta prompt that'll tell it to know or tell it what the date is, because models are also terrible at telling you what the date is. But again, things that it doesn't know. I need warm waterproof shoes to go on a hike. Sure, I can help with that. So here we've got a prompt and we've got a question that would probably rely on data that's outside of the model's training set. But what we can do is we can take the user's prompt and we can use a function or use memory to get an answer. So in that scenario, we would take, similar to the function, we would take the question, the prompt, and in addition to that, we would actually grab relevant information. So you can see there the documents to help us produce a better response to the user, as opposed to hallucinating or just not answering at all or saying I don't know. But adding knowledge to your models through memory or some other form is actually really important to be able to get them to answer precisely, concisely, especially on specific topics.
Question on that. So under the covers, is this adding those documents to its knowledge base of the pre-training? Or is it like prioritizing those documents as like the source of truth, then try to move back up?
So
Is it incorporating or prioritizing, basically?
both, but not through training. So what it's doing is this. When you go in and you ask a question, it kind of has a workflow or a or has orchestration that it runs through. So it would take your question, it would use that question to then go against a knowledge base or a retriever to get information that relates to that, the embeddings, the similarity search. So it would pull that data back. It would add that to the original user question or the prompt, and then it would query the model. And then then with that information, the model would be able to answer that question with relevant information and send back a response. This retrieval augmented generation is RAG. And for any of those, or any of you that went to or watched any of Build, it was the big thing. Everybody was talking about Build, or about RAG at Build. And as I said before, this is not really a new concept. I may have been late to LLMs, but I was early to RAG because I was talking about RAG a year ago. What?
I'm pretty sure I watched this shoe thing often.
I believe so. I believe so. Aaron, I can't think of his last name, but yeah, this presentation has been given, or similar variations of this presentation have been given a couple times at conferences from Microsoft.
Now, is this kind of what you would do, like when you're trying to parse the C# book? Because obviously So are you kind of doing more of this RAG piece when you're doing the C# book to get, because what is a method is a very, I mean, that's not necessarily C# specific or anything like that. So that kind of, you're using this in order to try to drive better responses based on context?
Absolutely. So, and we'll dig into the code here just a little bit, and hopefully at that same time I'll be able to get it working. I don't know. You know, it's the whole you make some small edits before a talk or public speaking, and everything breaks. What can I say? And this is where I'd go and show you guys the insides after showing you some more of the demo. But first, we're going to go look at the insides and hopefully get the demo working at the same time. That's really what we want. So this comes in a couple different pieces. So because of some of the goals of this Copilot, I've actually split this into like 3 main pieces. With the ultimate goal that this will be a part of the Essential C# website. You'll be able to go on there, you'll be able to ask questions about the book and get responses that are relevant. So the first piece of that is my, well actually, that's not the first piece. This is the first piece, the semantic vectorizer. So what this actually does is it uses a open source library called kernel memory. It's built by Microsoft engineers and is supported by Microsoft, but it is open source, so you can go in there, you can make contributions. The lead architect, Devis Lucato, awesome guy, really smart, got to meet him at Build. That guy's really smart. Anyways, he kind of built this off of learnings from another library that I'll talk about here in just a little bit called Semantic Kernel. And what kernel memory actually allows you to do is put out a service, either serverless, so in process, or as a service that you can call externally to store these embeddings, or to produce and then store these embeddings. So what we actually do is we send information into this service, and it goes through a couple different steps. First, it extracts the text from the document that has been sent in. It then splits that text. So that's splitting it into smaller chunks, also referred to as chunking. Chunking it into smaller pieces so that it can be embedded. And the reason that that's important is because there is a model limit. So the ADA model, I believe, is 8,192. Don't quote me on that exact number. But it's about 8,000 tokens that it can take in. So if you were to give it something more than 8,000 tokens, it won't actually produce a valid embedding for you. So by splitting the text, we guarantee that it's always smaller. There's also some strategy around how you want your Copilot to respond and kind of balancing the information with the cost. So the more tokens that you respond, or that you produce back as part of your memory. So let's say we went the full 8,000 tokens. By the way, tokens are approximately 0.75 of a word. Now that seems weird, but it's because of the way that, you know, the sizing is done. Anyways, so you've got what, some 6,000 words that are coming back. First of all, that's a lot of information. Second of all, that's going to be 8,000 tokens that you're sending in every single time you use that embedding as part of a prompt that you're generating a response with. So there's strategies around reducing that while maintaining context. So people do it by heading. So if you've got like a document that has headings everywhere, but they're not like huge bodies of text, you can do it by heading. You can do it by paragraph, pages even. So there's strategies around that, and everybody does it kind of differently. In our case, we took the markdown representation of the book. We first split it by heading, and then based on the sizing of that, we further split it by subparagraph underneath. From there, we also generate slugs. So this is, and if I can get this working, if I can show you, is how we actually get the URL for the content. So this does quote its sources. So you can actually go and see the original text that it's producing the answer based on. We then generate the embeddings, and we save the memory. So For embeddings, again, I'm using Ada 2, pretty common model. I have a lot of familiarity with it, which is why I'm using it. Though there are some really cool embedding models that are coming out that are smaller, so you can reduce the size of your actual database that's storing this information. And then for the actual vector database, I'm using PG Vector, which is an extension of Postgres. Postgres can do anything. What can I say? I love Postgres. If you're not using Postgres, you should use Postgres too. So anyways, so we perform these 5 steps against all of the pieces of like knowledge or of text that's coming in, and we produce a vector database out of that. The next piece of this is the actual oh, I got to change my screens. One moment. Next piece of this is the actual like prompting, or the actual like interface and orchestration. So for this, we are using another library that I referenced earlier, Semantic Kernel. It is another open source library or orchestration framework produced by Microsoft. It's awesome. It's really powerful. It allows you to do all kinds of different orchestration, whether it be you've got a sequential set of steps that you want the system or the copilot to use, which can include like those functions, going out and grabbing stuff from an API, using your own methods that you've built in, so replacing like math, answering math questions with actually doing math computationally, and then giving that answer to the LLM to produce a response. It allows you to do things like Merkle chains, and there's another name for that. I only ever know it by Merkle chains, but that or planning. So you can have the LLM take the original prompt and do its best to produce a set of steps that it needs to go through to then answer that question. It would then take each one of those steps as a sub-prompt, and it would answer that using tools or functions. So it allows the LLM to break down a huge complex problem into smaller sub-problems until it gets to a point where those are good questions to ask, or things that it can accurately respond to. Those things, and honestly a whole lot more, what is it? Plugins, planners, and personas, as the Semantic Kernel team says, the 3 Ps. Also really cool guys too. But what we do is we use Semantic Kernel to do the orchestration. So this takes in our user prompt, it then goes out to the memory, grabs the relevant information that it needs to answer that question. This, again, if it would work, if it worked, it also has a math plugin, so it'll do basic addition using actual computation. So this is the second part of it, and the third part of it is just the actual service that does the responses. So we've split the taking in memories apart from the producing, or retrieving memories. But this uses embedding model, Postgres for its database, and is able to store files. Again, I cannot say this enough, kernel memory is really cool. It's really deep. It handles things like replacing old memories. So if you've had a piece of text or if you have a document and you edit that document and you re-upload it, it'll remove all of the old memories so that you don't get hallucinations back to information that's no longer accurate. It stores intermediate steps, so if it dies, you can actually recover from that if it's in the middle of producing the embeddings. A lot of really cool stuff that's pre-built for you that if you were to build it by hand would take forever. But that's neither here nor there. I'm going to see if you'll grant me 2 minutes. Let me see if I can get this working again. And of course, my Visual Studio just wants to enlarge everything under the sun. Like I need to see any of this. Thank you very much. Yeah, I know you complain about stuff. I know. Failed to connect. Yeah, I know. All right. So Start the corpus service again. Should be, yep, we should be good there. And let's restart our actual assistant here. No, wrong one. There we go. Okay. Crossing fingers. Yeah, what did I do? Super disappointing. I'm sorry, guys. I don't know what I did in the mere 20 minutes prior to this presentation. And I'm sure as soon as I sit down and actually, focus on it, it'll be a relatively quick fix. I also don't want to waste all your guys' time. I will produce content for the recording, though, so that if you go back and review this or are viewing this for the first time, that you'll be able to see this. Finally, just a last few things before we close. AI. It means a lot of things, but right now it's mostly generative AI. But it really does mean a lot of things. There's a lot of cool stuff out there. A lot of cool models that are not large language models. Azure OpenAI service for your GPT models. Azure AI services for almost every other model. Your Phi 3 models, your Cohere models, your Mistrals, your Llamas, your everything. They've got a ton of models on there. A lot of cool stuff. If you haven't checked it out, Azure AI Studio. Really cool. You can self-host or use serverless, pay by tokens. It's great stuff. Semantic kernel for orchestration. I will give these slides with links in them at some point. I don't know. I can produce a link for you guys to go check out semantic kernel, as well as kernel memory for your semantic memory management, and then PG Vector for Postgres. If you're going to do vectors and you like open source databases, PG Vector. Now, we get to the great part. We started with this. We're going to end with this. The demo didn't work. I'm sorry, guys. Don't hold it against me too much, but it is kind of my fault for editing things last day. But either way, please go respond to the survey. Let us know how we did. Microsoft is using these responses as part of a determination on whether they're going to produce more content like this, these community pilots. You just got unlucky that I wanted to do my own demos instead of using the demos that they pre-canned for me. What can I say? Also,
just before you made those changes, right?
Yeah, totally. No, I didn't just spend all day making changes and then didn't commit after every small change that I made. What am I, a developer? But if you'd like to see more content like this, minus the not working demo, go let them know that you want to see more stuff like this. It's really great. It's really cool that they put this stuff together and they kind of push this out to the community. Next, some announcements. We've got the Python user group on June 18th at 6 p.m. It will also be hosted here. Great stuff if you like Python. My cup, one side has .NET, The other side has Python. Other cool thing about semantic kernel, I know, I'm sorry, I can't stop with this semantic kernel thing. It's in 3 languages. So you can work with a team that's, prototyping in Python, really easy to prototype, and then you can take that same, the same concepts, the same, overall structure, and put that into like .NET or Java, something you'd see in more of an end-line system. Anyways, moving on. The DevOps User Group, the Global DevOps Day. So Intellitek is hosting the Spokane region location for the Global DevOps Experience. It's going to be a almost all-day event. I will be one of the hosts. I promise I'm not producing demos for that. But what we'll be doing is going through simulation of a real-world scenario, solving problems using DevOps tooling, GitHub, Azure, and AI. So should be pretty fun. I'm pretty excited, and I hope to see a bunch of you there. The Rust User Group, June 13th at 6 p.m. The Rust User Group's leader, Joshua, great guy. If you haven't done Rust and you want to learn Rust, this group likes to go over really beginner topics, not because they can't handle complex topics, but because they know that Rust is a complex language and most people don't have familiarity with it yet. So check it out, it's great. And finally, the Spokane Tech Sizzlin' Summer Barbecue, which will be hosted on June 14th at 5 p.m. on the Saranac Pub rooftop. If you want to talk to a bunch of like-minded tech adjacent folk that love Python, DevOps, Rust, .NET, there's also a Go user group. Go check it out. Enjoy the company. That's it. Thank you. I hope you guys have a wonderful rest of your day, and peace.